Okay, so welcome to the third session of ArcGIS in this lecture series on spatial statistics and spatial econometrics. We will pick up from where we left in the second session. So one thing I forgot to do while I ended that session, and that can be fatal at times in terms of analyzing spatial data. So I did it a little bit on purpose, is to save the project. So we should not leave our chairs after we have spent an hour, half an hour, 2 hours, often more hours working on these data. So the screen is exactly where it was, when I left. So what you see on the screen is the same snapshot. So I'm going to just, close the measure, tool, and I'm going to save the project. I'm going to save the project. It's saving the project on my screen. Now it's saved. The beauty of saving the project is that I can now close this and start right at this junction where I left. Let me show you. Okay, I'm going to now close it. Okay, so now it's gone. I go to the folder Gaurav ArcGIS, practice sessions, and here is my project. Under project, you see a 33 kilobyte file, which is SSSE ArcGIS project. If I double click it, it will just start ArcGIS Pro. And now at the same point where I left my screen a minute ago. Okay, it has started, it's loading map, it's doing everything. It's just loading the same project. Okay, wait for it. There we go. Fantastic. So it has everything exactly at the same location, at same point where I left my project. Okay, so I can also, by the way, take the project file and take it to a different computer. Let's say my home computer is different from my office computer, and I can distribute time between working on these projects. The only one thing to be very careful about is that the data location should be same. So the data should be located in the same exact structure as it was on this system, right? For it to read those data. If it is not able to read the data, you can actually go out and change the locations and work with them. Okay. All right. So now I have my data. Again, I'm going to now focus on Uttar Pradesh going forward. So here is Uttar Pradesh. The black boundary demarcates the state from other states. West of Uttar Pradesh is Haryana, National Capital Territory of Delhi, Rajasthan. South is Madhya Pradesh, Chhattisgarh. East is Jharkhand and Bihar, and north of Uttar Pradesh is Himachal Pradesh and Uttarakhand. Okay. Say for a particular project that I am doing, it is only focused on Uttar Pradesh. Okay. Then how do I work with files when I do not need other files? Okay, for symbology purposes, I want to sort of, draw a map, show my audience, international audience who may not be aware of different states in India. Hey, I'm looking at this northern state of Uttar Pradesh. But then going forward, then I'm conducting my analysis. I don't need the entire map of India. I don't need all the states of India. I only want to focus on Uttar Pradesh, right? So what do I do? So for that, I'm going to now clip the features by the state name. And I'm going to now create files which are only focusing on Uttar Pradesh. Okay, so let's try to do that. Let's start with the easiest file, which is the state file. Okay, right click. Okay, I am going to say attribute table. Okay, under attribute table, I have this, this top, tab area where I have field. It says add, calculate, selection. And it says select by attributes. Okay, so I'm going to say select by attributes, and I'm going to say select new selection. Where should I look? You should look at name 1, and name 1, it automatically picks the names of the states, and I'm going to say I want to please pick Uttar Pradesh for me, and I'm going to say apply, and it selects state, the state for me. I can also go to the row and click and select the state. I know that, right? But I'm now selecting by this state. I'm going to say OK. So once it's selected, it has selected Uttar Pradesh. I'm going to now go and right click on this one, on India ADM1, which is the state file. right? I can refer from my folder. I can rename the file here as well, right? Let me do that just for my, let me rename, okay, I'm going to just click on it. Okay, I can now, I'm going to say states, just for my purpose. I'm going to, before I do any clipping, I'm just changing the name for my purpose. Okay, states, districts, then we have taluks, right, and ADM 0, we didn't change it here. Okay, so it's the national level file from DIVA GIS. Okay, so whenever I make changes, I always save my project. I'm going to just save my project. Okay, now I'm only focusing on the states file. So India states, I'm right clicking and I'm going to data, and I'm going to say export features. I can export features and I can export just the table. That's the CSV. Okay, I'm going to say I'm going to export features, and it says, okay, you want to export features, okay, fine, output features. Okay, I want to now change the name of the output features. I want to go to the same location, Gaurav ArcGIS, practice sessions, India admin data. I am going to say, I'm going to name this as Uttar, or let's say, yeah, I'm going to say Uttar Pradesh, okay, state from DIVA GIS. Save, okay, and it creates a new layer called Uttar Pradesh state. If I uncheck the India states, they will all go away. I can now say zoom to layer. When I do zoom to layer, after right clicking, what it does is, whatever pane size I have, it just fits the map there. There you go. Okay, it doesn't just do that, it wonderfully also adjusts all the other panes also accordingly. Okay, now I see Uttar Pradesh and I see all of its districts. Okay, I see other districts as well, but I'm not interested in the state boundaries anymore outside of Uttar Pradesh, because that's, as an analyst, I am choosing to analyze the data for Uttar Pradesh. I can also change the size of the attribute table, and then again do this zoom to layer and see what happens. Here we go. It uses the entire space. Okay, so it's very smart that way. I can actually close the catalog pane, again do zoom to layer and see what happens. Okay, nothing happens because it's already adjusted its extent according to the given size of the pane. Okay, fantastic. So now I have this feature sitting here as Uttar Pradesh. I can go back to my catalog pane, go to my folders, Gaurav ArcGIS, practice sessions, and now I should be able to also see Uttar Pradesh shapefile. The icon in front of this shapefile is a polygon file. Okay, if I go to roads or I go to railroads and I actually drag it and bring it here, you will see these. Okay, I can go to its symbology. I'll change its color just so that we are able to see these are the railroads provided by DIVA GIS. Okay, now I can see where the railroads run across Uttar Pradesh. What's the density within each district? I can visualize it. It seems to me there is some important town here because there are many intersections of rails here. And if I click on World Topographic Map India, I will actually know what this location is. Well, it's Lucknow, it's the state capital. So of course, the density of railroads was characteristically high in that area, right? Very interesting. Okay, all right. Now, if you look at what I wanted to also point out here is that if you look at the icon in front of India Rails, it's actually a line. This is again a vector file, but it's a line form, right? The vector data are stored as lines, whereas data in case of Uttar Pradesh state is a polygon shape. So the icon itself is identifying what kind of vector data are we looking at. Okay, that's that. So I'm going to now uncheck the India Rails. It can sit there. I have no problem with that. I'll make the catalog pane smaller. I'll again zoom to layer, to my Uttar Pradesh layer, so I can look at Uttar Pradesh. It's again still labeled. If I want to remove the label, I could just click on label and it'll remove it. Okay, that's fine. All right, so now what if I want to clip the districts as well? Okay, so I'm going to go to districts. I'm going to say attribute table. Under attribute table, same strategy. I'm going to say select by attributes. I want to select by, again, name 1, when name 1 is equal to Uttar Pradesh. Let me do that. Apply. Okay, now it selects everything in that polygon which comes under the name 1 category of Uttar Pradesh. Okay, I can again go, I can say right click, I can say data, export features. I want to change the name, I want to go to the folders, I want to go to my desktop. Yeah, so I can say Uttar Pradesh districts. I'm just going to say from Diva GIS, instead of Diva GIS, just make the name a little shorter. I'm going to say 1 because I'm going to show you an alternate path of clipping the features, okay, an alternate strategy of clipping the features. So right now, let's just clip the features with the select attributes methodology. Save. Okay, it's saving the features and it gives me a new layer called Uttar Pradesh Districts 1. If I deselect other districts, the entire country's districts, fantastically, it only gives me, the districts of Uttar Pradesh. Okay, and if I open the attribute table, okay, so the attribute table for India districts had 667 units. That means the India layer has 67 districts as far as this data is concerned. And 75 of those were selected. That means 75 should be the number of districts in Uttar Pradesh. So if I look at the attribute table for the Uttar Pradesh Districts 1 file, attribute table, it will in all have 75 units or polygons. So there are 75 districts. I can select them differently. They are all sort of, there to be seen. There is Amethi. That's where Amethi is. That's where Azamgarh is. This is Balia on your screen. I can also look at some others. Let's say Chitrakoot. I can look at Bijnor, which is your sugarcane belt, right? There is Gautam Budh Nagar and Ghaziabad, the two urban settlements on the east of Delhi. The satellite towns of Delhi. They are themselves districts, right? I have Ghazipur, Fatehpur, Firozabad, Hapur, Hathras, and so on and so forth, right? So I can now sort of move across these units and try to locate where they are on my map, right? Okay. Within these districts, I may also want to do some labeling, right? I may want to do some labeling. So let me just remove the selection. Right? Okay, so I can go and I can say labeling properties on Uttar Pradesh districts file. I can say labeling properties. Let me label these. Okay, all right. I have my class I want is name 2 because I want district names. So I want to remove this feature and I want to say name 2 and I want to say apply. Okay, I can also go and I can change the, like I said, I like Times New Roman. Now I want the size to be smaller because I am aware that there are going to be 75 different names being written in those little polygons. So I'm going to just make it 8 and I'm going to say apply and I'm going to close this. Going to go back to Uttar Pradesh Districts 1, right click, I'm going to say click label. There we go, fantastic. So now if I zoom in a little bit, I can actually see all the names of different districts assigned to their respective locations. Okay, so now I can see Mathura, I can see Gautam Budh Nagar, I can see Ghaziabad, I can see Bulandshahr, I can see Amroha, I can see Firozabad, I can see Kasganj, I can see Jalaun, Jhansi, Mahoba, Lucknow, Barabanki, Sitapur, Lakhimpur Kheri, Gonda, Balia, right, Azamgarh. Gorakhpur, and so on and so forth, right? So I am able to now visualize at once the spatial structure, organization, or spatial organization of districts in the state of Uttar Pradesh, right? Okay, so I've done that. So I told you when I began this exercise that I'm going to show you an alternative, path or methodology of clipping features. So what did I want? I have, I have an India level districts file. This is an India level districts file. Here for now, we have the selection of by attributes inside Uttar Pradesh. And I have this sitting feature, which is, let's say, my polygon within which I want to clip the data. So I can go to view and there is something called geoprocessing, right? So I'm going to click on geoprocessing and it's going to now, it's going to give me 3 tabs: favorites, toolboxes, and portals. Favorites provide me the favorite features that were probably, on this system were used many times earlier, by someone else. It's like the favorites that I have on this system. It's a memory that the software pertains. But what is most important for us is this portal, this toolboxes, right? These toolboxes, you can see, have many sort of little toolboxes, and within those toolboxes, there are these subtools. Okay. Now, focus on the analysis tools. Under that, we have overlay, right? We have extract, we have pairwise overlay, and so on and so forth. Each of these tool does some kind of manipulation to the given spatial data. Okay. The tool of interest for me right now is analysis, extract, clip. So let me double click. Okay. So it gives me input features. What are your input features? You can click and figure out what is this all about. You can actually click on the question mark and it will give you a very, very nice description. That's why this software is paid, right? So you have clip, which is an analysis tools. What does it do? It extracts input features that overlay the clip features. So I have an input feature, let's say the districts file, it's a bigger file, and then let's say I have a clip feature. The clip feature here is the Uttar Pradesh state boundary. Such a clip feature can come from some other source as well, right? I mean, you can, as an analyst, source such features from different, from a different location. For example, it may be a river basin, right? I'll show you in 5-10 minutes, I'll show you an India water resource inventory system, which is a fantastic, spatial data set. Well, you have to construct spatial data sets from there, but it's a fantastic data set for water resources in India, right? So you can bring in a basin, and instead of the state, if you want to study something within a basin, let's say the Ganga basin, the Yamuna basin, and so on and so forth, then you may have a shapefile, a polygon of the shape of the basin, right? If you want instead to study, let's say, a region which is a climatic region, right, which is an agricultural region, which may be an ecosystem. It could be, for example, the Jim Corbett National Park. You want to only focus on the Jim Corbett National Park, then you need a shapefile, a polygon, which is externally sourced from, let's say, the India's wildlife, inventory, areas inventory, and they may provide you a shapefile for the Jim Corbett National Park. So if you have such predefined areas of interest or features that you want to study data for, and not everything else inside a state or inside a country or inside a given larger region, then you can clip the features inside that area of interest, right? Here, my larger region is India's district file, and my area of interest is the Uttar Pradesh extent. Okay, so I'm going to now clip the features and so that they are only contained in that file. Okay, so input features drop down will catch all the files in the map drawing order under contents. So I want India districts from Divya GIS. My clip features are Uttar Pradesh state from Diva GIS. Output feature, I'm going to open, I'm going to search for okay, I have districts, I'm going to say this is districts 2 because this is method 2. And I'm also say clip because I'm identifying that I'm using the tool clip from analysis. analysis, extract, clip. Save, and I'm going to say run. When I say run, it's going to actually run the module. Okay, it says running and it's done. Now I have Uttar Pradesh districts to clip. Okay, all right. So I'm going to close geoprocessing and I'm going to now analyze the two. I'm going to uncheck the India level file. Okay, I have one now file open which is India districts 2, which is looks exactly the same as India districts 1. To visualize that, I'm going to go to symbology and I'm going to change the color of this to green. I'm going to make it thinner. Okay, apply and close. Uncommitted simple formatting. Do you want to know what happened? Okay, so something. All right, so here is my. Okay, this is Uttar Pradesh District 2, just like District 1. It has 75 features, right? I think I did something wrong with its symbology. Let me go back to symbology. Let me see if I can, I think okay, let me do one thing. Let me undo something here. See if I can get my symbology back. Yeah, I get it back by undoing. Let me save things till here. Okay, save project. I'm going to go back to its symbology. I want to change its outline color. I want to change its color. And I'm going to say apply. Okay, it applies it. And if I open the other one, which is sitting behind it, and I make it slightly thicker, then I can visualize both. Okay, so now I have the India or UP Uttar Pradesh districts 1 and districts 2 files, which look exactly the same, but they were recovered with different methodologies. Okay, so I'm clipping the data, I'm bringing it in, and I can actually just work with Uttar Pradesh data. Okay, so this is a particular modification that I have done with these data. And going forward, the next step that what we are going to do is we are going to look at a points level data. Well, we could do one thing as homework for you guys. Okay, so remember we looked at the railroads. So we could bring the railroads here and you could try to clip the railroads. Okay, what could you do then? Well, you will go to your analysis, we'll go to the tools, we'll say view, geoprocessing, clip. Now the feature that I'm interested is India Rails. Okay, so I'm going to say 1 and 2 because I've opened it twice. So I'm just going to say Rails 1, it doesn't matter. Then, the one that I really care about is UP state and I'm going to clip it. And I'm going to call it Uttar Pradesh railroads, and I'm going to say clip because I am using that function, and I'm going to say shape, save, and I'm going to say run. And if I now uncheck, okay, clip completed, okay, done, fantastic. I'm going to close this and I'm going to now remove, and now I am able to visualize. I'm just going to keep one of them. Let's see. So I'm now able to visualize the districts and the distribution of railroads on UP, right? So you can do this for roads, for inland waterways. We can also look at the attribute table of this and see what the railroads data actually has, the CSV file has. Okay, so it has, it says it is a railroad, it is operational, it is a multiple or a single railroad, single line, multiple line, right? India, ISO country. It has a rail ID, so you can, if you select a particular rail ID, it's going to select a particular line. There we go, right? So it's a join of different lines. There we go, right? Right. So you can see how these line features are joined together to store information. We can do one very interesting thing. We can calculate the length and the area of these units. So let's say we say add field, under field we say add, right? And we can type the name of this field. I can say length, and I'm going to say I want it to be long. I actually like double, and this is it. Okay, I'm done. All right, so I can then just close it. Done. Current layer, yes, done, done, done. Okay, I don't want that. All right, so done. Save all changes, yes. So if I apply changes, it's going to add a new field. Fantastic, it adds a new field. I'm going to deselect the one that I had selected. I'm going to zoom to layer. I right click on length and I say calculate geometry. Calculate geometry. When I want to calculate geometry, I want to tell what coordinate system I'm working with. So I'm working with the coordinate system of this particular one, which is GCS WGS84. And I want to calculate the property. What property I want to calculate? I want to calculate the length, right? What unit of length? Well, I want it in meters. Okay, I want it in meters. And then what I want to do is I want to say okay. As soon as I say okay, what it does for me, it actually calculates the length of each feature in meters. Fantastic, right? So each little feature is now calculated in meters. I'm a little worried that the numbers are very small for meters. That would mean that, oh, there are 292 of these lines. They are certainly not meters, even though I asked for it. So I can do one thing. I can go to measure, and I can try to, see what, okay, I need to, okay, and okay. So I'm looking at overall 187 kilometers. So it is giving me 1.85, which basically means I have now 1.85 into 10 to the power 2 kilometers. So that's how we cross-validate the unit that we are using. Sometimes because of the coordinate system or some kind of internal calculations, we may see some of these weird kind of variables. What we then do is we simply just cross-check using the measure tool. So now I know that the numbers that I'm looking at are just your hundreds of kilometers. So 1.85 multiplied by 10 to the power 2 kilometers. Okay. So what I'm going to do for the benefit of my own self, I'm going to try and rename the field. So I'm going to just say it's can I just change the name? It seems like it's going to be a little bit more complicated, but I can rename the field and I can just call it hundreds kilometers. Okay. So that is something I'm going to leave to you, that you can figure out a way to change the name of the field which reflects its units also. Okay. So once I've done that, as one step, now I want to, let's say, I want to know, as a next step, I want to know, okay, what is the length of, a railway line within each district? Okay. So I want to do that. I have a separate file which for Uttar Pradesh, okay, both files are for Uttar Pradesh. So I know very well that for Uttar Pradesh, I have, district data. I can identify these districts, but I can't tell within Muzaffarnagar what is the length of rail line and how does it compare with the rail line length in Bareilly. Okay. So for that, I will go back to my analysis, my view, my geoprocessing. Under analysis, I have, this tool under overlay called intersect. Okay. Let's look at this tool. Now let's see what this tool does. Interestingly, this tool will basically intersect two files over one another. So what it does is, let's say I begin with this feature input and I begin with the feature, this intersect feature. As an output, it gives me the feature being clipped, as one, right? So what it'll do is it'll now create polygons by the names of the rail line or the ID of the rail line and the district. Okay, so let's try and see what we get. So input features, the first input feature, that is the parent feature that I am interested in, is UP districts 1, and the second feature that I am interested is UP railroads clip. This has rank 1 and this has rank 2. Rank 1 is the file which will determine the extent of the resulting feature, right? I want to retain the districts feature. I don't want to just retain the rail line feature. It can do that, right? I want to retain that and I want to then intersect the two. So let me do that. Okay, so output feature class, I will go and say I want to stake Uttar Pradesh districts, UP districts and railroads clip, oh sorry, not clip, intersect .shp, and I say save. Okay, I want to join all the attributes, and output type is same as the input, which I want is to be basically a polygon. That's why I've given rank 1 to the polygon shape. If I give the rank 1 to the line shape, then the resulting output will be the line shape. Okay, so I'm going to say run. Let's run this. It's running and it's done very quickly. Now what does it give me? Okay, I need to close down both of these things, and now I see what I see is wonderfully a UP district railroad. Okay, what is it that I see here? Okay, so let me now just show you what do we see. Attribute table. Okay, so let's look at the attribute table. Now the attribute table has 437 units. Why? Because each unit has been now broken down by the rail line that lies within there. If there are more than one rail lines or rail line objects inside a district, it's going to now count it as 2 objects. Okay, so then I'm going to now look at this thing for Muzaffarnagar, which was my something of interest. So let's go to Muzaffarnagar and see what we get. Okay, so all right, so now I have my UP districts railroad. I want the railroad, not the district. So okay, I'm gonna check it. Yes, UP districts railroad. Now I have FID Uttar Pradesh. This is the FID related to the districts file. Name India, name 1 Uttar Pradesh, name 2 Muzaffarnagar. Keep going, and then it has FID Uttar Pradesh rail ID. There is one rail going through it, which is a single line, and it has a length of 94 kilometers. Okay, so one rail which is going through 94 kilometers. Here on the CSV or the Excel sort of type of format on the attribute table, let's close all other attribute tables to focus on this one. Okay, what do we have? We have the first unit is a polyline, so it's a polygon and a line, so it's an intersect of the two. It's a polyline. It is Saharanpur, it has Saharanpur in it, and it has a railroad of size 22 kilometers or 23 kilometers. Now, interestingly, Saharanpur is occurring occurs once, twice, thrice, 4, 5, 8 times. So, Saharanpur was made up of 8 line objects that were representing railroads. And to see the total size of rail lines within Saharanpur, I will have to sum all of these and multiply it by 100, and I'll have the kilometer length within Saharanpur. Okay, so if I go back to my map and look at the selected area, it'll make much more things interesting for me. So here is Saharanpur, and Saharanpur, if I go back to my district file, Saharanpur has all these rail lines. Well, it has more, so it will show up later as well. So this is not going to be all for Saharanpur then. Yeah. So I'm going to have to see if I can select by attributes, and I'm going to say name 1 on, let's say name 2, and I'm going to say give me Saharanpur. Apply. Okay, there you go. So now all the rail lines within Saharanpur are selected, and now you can go in and you can actually just sum the length for all the selected areas, and you will get the length of rail within Saharanpur. You can also export these data, by the way. You can export these data, okay, to Excel. So you can say, you can go to Uttar Pradesh district, you can say data, and you can say export table. I want to export the table, and I want to say output table. Where should the output table be? Let's just wait and see if we can, export it. Okay, so we can say Uttar Pradesh UP districts railroad. I don't want SHP, I want a table. Save. Okay, now it will add a table file, separately for this one. And you can also sort of go to the attribute table, click on the 3 button, and here it will say export. Okay, you can export this file. You can just say output table. Here, you will be able to again save the same thing as a table. It saves it as a .dbf file. I'm just going to call it 2 because this is the second method that I have for saving the table. Okay, okay, so it adds it here. So if I close this, I will be able to double click and open this table by right clicking, open. Here we go, right? So here I have the table which is separate from the file itself. I don't need the file anymore. I can just look at the table, right? Okay, so that's about it. I'm going to save my work. In the next class, in the next session, we will go over exporting these data to Excel, and then we will go on to working with the points data set, which is which will be a groundwater data set. Something that you have seen in so many lectures in your theory classes. You will actually be able to work with those data. I'll show you where to get those data. So the first step in the next class will be to take this, export these data to Excel, right? To just take it to an Excel file, and then from there on, you are free to use it in your any statistical software like Stata, R, Python, whatever you are comfortable with, right? Or you could just work on Excel, right? So which is very convenient, right? That will be very nice to do, right? Okay, so let's end it here. I've saved my project, and I will start right here in the next session, and we will go through. First step will be take it to the export it to the Excel file, and second is start working with groundwater data for Uttar Pradesh. All right, thank you for your attention.